Okay, hello. Today I would like to go through this sample problem with you from homework number 2 for Coulomb's law that we went over in class today, but you might not have been there or would like to see it again. So the problem is we are asked to find the total net force on Q2 due to Q1 and Q3. So we have 3 charges on a line, as you can see here, Q1, Q2, and Q3. We know the size of those charges and we know how far apart they are. So all 3 of these charges interact with each other, but we are asked to just focus on Q2 and find the net force on it due to 1 and 3. So I'm going to put a little box around Q2 because that's the charge we're focused on. So charge Q2 has 2 forces acting on it, and we are going to calculate the size of those 2 forces and then figure out how to combine them. So we start here with Coulomb's law, F equals K Q1 Q2 over R squared, and we're going to substitute in our values. Our value for K is always the same, 9 times 10 to the 9th. Our value for Q1 is 1.5 times 10 to the minus 6. Our value for Q2 is 3.0 times 10 to the minus 6. And the distance between these 2 charges is 0.02 squared. So we're going to plug those values into our calculator, being very careful to use the EE key and not the times 10 caret. And when we do that, we will find that the answer is 101.25. This answer will be in newtons because it's a force. Now I would like to think about what the direction is of this force. This is the force that Q2 feels because of Q1. Q1 and Q2 are both positive charges, so they repel each other. So this force is to the right because Q2 is repelled by Q1. So we will put right here, and that is our first force. Now we are going to do the same thing with Q2 and Q3. Let's plug in our values here. This one will be a little bit different because of the sign of our charge. 9 times 10 to the 9th. Our Q2 is the 3 times 10 to the minus 6. And our second charge, our Q3, is our negative charge. But in this situation, we do not include the negative of the charge there. And we just write 2.0 times 10 to the minus 6th. We do want to keep the negative on the exponent, but not the negative that's in front of the charge. The distance here is 0.1 meters, which will be squared also. When we calculate this number, we will find that we get 5.4. This number is in newtons also because it's a force. And let's now think about the direction of this force. This charge Q2 is positive, and the charge Q3 is negative. Those 2 charges are attracted to each other. So Q2 is pulled to the right again by this force. So now we want to combine them and figure out the net force. We have one charge to the right of 101.25 newtons, and we have another charge to the right of 5.4 newtons. And in order to figure out the net force, we're just going to add those together because they are both in the same direction. So this leaves us with a net force of 106.65 newtons to the right. And now, hopefully, you can think about trying problem number 2 on your homework.